How's the conference been? Very good. All right. Cool. Welcome to my talk. I am Kunal, and I work at Civo. And we're excited to be here in Tampa, all the way from London. Very nice weather. And today we're going to talk about platform engineering. Can you please show a raise of hands for folks who know what platform engineering is? Okay, can everyone show a raise of hands if you think DevOps is dead? You know, some people say DevOps is dead. If you've ever been to KubeCon, you'd see many booths that say DevOps is dead. And anyway, that was a booth at KubeCon. But anyway, the agenda for today's session is we're going to talk about platform engineering. I'm going to try to keep it as laid off as possible. I'm not much good with definitions, and if you had asked me what platform engineering is like a year ago, 2 years ago, I would have been like, I don't really care, you know? What problem is it solving? Is it something of interest to me or not, right? That's the sort of kind of a guy I am. I'm a simple guy, and yeah. Don't like to overcomplicate my life. But then everyone was talking about it, so I did my research a little bit, and here we are. So we're going to talk about the evolution of platform engineering, how we started, where we are now, role in modern organizations. We're going to talk about how to do it, so internal developer platforms and SaaS solutions. We're going to see which one to pick based on a decision-making framework. And I'm going to show you some demos as well, using some nice open source projects. So, what is platform engineering? Before I move forward with the definition, think of it this way. Imagine you want to, who likes Legos, first of all? Show a raise of hands. Right. So imagine you want to build a very cool Lego castle or something. So when you buy a Lego, it's not all jumbled, right? You don't get all the Lego bricks like random. You get a book. It has nice instructions, pictures. You get various sections of the Legos in like plastic papers or whatever. So platform engineering is like preparing that box of Lego bricks for you, and it makes sure that all the different types of bricks that you need for building a castle, like the windows and doors and walls, they're all organized and easy to use. So this way, you can focus on what? Building your castle, and you don't have to worry about making the bricks yourself. Now, when we talk about programming, platform engineering is like preparing this box of tools and parts for whom? For developers. So developers don't care about, which Kubernetes cluster version you're running or all these other things. They just need like, ideally, I don't know, MySQL in production, and they wanted it yesterday. So think of it like it gives developers everything that they need to build their computer programs, like infrastructure, storage space, security, any special software, whatever it might be. And because they have this box ready to go, programmers can create their websites and applications more quickly and easily. And yeah. On a more technical term, platform engineering, the definition is it drives organizational sustainability by practicing socio-technical principles that provide a community-driven support system for application developers using standardized shared platform architecture. So there are 3 pillars to it. The first one being architecture, community support, principles. We're going to talk about it later. And advantages. I won't go too much into this because time is short. I want to do a demo as well. But ideally, you all can guess. Because developers don't have to worry about the platform themselves, it saves them time, so they can create their apps faster because they don't have to build everything from scratch. The platform provides the tools and services that help make it better and more reliable applications. Also, it's cheaper because you're saving time. Because you're saving time, you can experiment, people can try out new things, be more creative, and other things like handle growth as the application grows. Because you are a developer, you're focused on writing your application. The platform part and management part and infrastructure part, it's not your problem. It's being taken care of. And similarly, other thing you don't have to worry about is keeping things running. So making sure that your apps are running well all the time, reduced crashes or problems. Why is this yellow? Is it yellow for everyone? Interesting. All right. But yeah, benefits can keep going on and on. Improves security, which is also a part of platform engineering, and just updating and improving the applications over time as well. Okay, I was I was just talking to this one person at a conference, and I was like, okay, this is what platform engineering is. You have a platform, and you give it to people, and they build applications on top of it. Okay, not a problem. So the question arises, is an operating system sort of like an example of platform engineering? Because you have your operating system, and you have applications on top of it. Who thinks yes? Is it like the same principle? Just one person? Yeah? I really don't like core definitions. There are so many things. React is a library, not a framework. DevOps engineer is a role, it's not a role. I'm way too young to be worried about these things. But that was an interesting point. I personally think that the ideology is simple. It's just working in a different way. Operating systems providing more like a hardware abstraction, if you will, between like the kernel or whatever. But I think in hindsight, the overall thought is simple. You have your system, and you want to make it easier for people to build stuff on top of it. We'll talk more about it later. Speaking of which, bringing me to my next slide. Let's time travel a little bit. Very early days, what used to happen? Platform engineering, I would say that recently has picked up momentum, but it's not something that people have not already been doing in various ways in the past few years. So in the very early days, everything was manual and basic. If someone wanted to build an app, they had to set up servers themselves, configure networks, and handle all the technical stuff. It was like baking a cake from scratch every single time. I got this from Dali, so that's why. So I'm taking a cake analogy, and I haven't done this before, so let's see how that goes. And next came rise of cloud computing. So imagine instead of baking a cake from scratch, you could just order it from the bakery. Cloud computing lets the developers use the servers and services over the internet without having to own them. So this made things a little bit more easier and allowed for more bigger and more complex applications. Does anybody know what came next? DevOps? So a mix of development and operations became a very big deal. Regarding the cake analogy, it's like having a kitchen robot that helps you by automating a lot of tasks and basically helping you building and running your applications faster, more reliable. Next came microservices, containers. Everyone has heard of Kubernetes. So imagine, let's say, I gave a Lego example in the past. So instead of building the entire Lego structure, each part, like the kitchen, living room, etc., is like a separate block that you can move around. So this made apps more flexible. We talk about microservices and containers now. What was next after that? Any guesses? Yeah? Platform as a service, or like serverless also? Simplicity, focus. More recently, we are seeing this growth. It's like you want to make a movie, but instead of worrying about cameras and sets, you are just directing and acting. And PaaS and serverless takes care of all the technical background tasks, so developers can focus on building their applications, writing code. Okay. Bringing to my next point, is DevOps dead? What is DevOps? Combining development and IT operations. Then what is platform engineering? Platform engineering, I already gave a basic definition, but it's an evolution of the principles behind DevOps. So DevOps has like the automation and efficiency goals that it has set. It takes it a little bit step further by building a more standardized and accessible platform for developers. As the name suggests, platform engineering. You're making a platform for developers. I know it's confusing. Let's break it down. DevOps versus platform engineering. So platform engineering, in simple terms, I already gave the technical definitions. I'm not going to go back to that. I'm going to do the layman language. So it's like building a solid foundation, like servers and tools and services for developers to use. I made this platform. I set up Kubernetes. I set up CI/CD, GitOps, databases, and now you can use it, build your platform. Okay. DevOps, in contrast, is more about the process. So how the development and operations teams work together, automate workflows, and continuously improve their practices. So when we talk about the primary goal for DevOps, it's to shorten the software development lifecycle, increase deployment frequency, and create a more dependable release process in alignment to your business objectives. No worries, Chad. Chad has a very nice book if you want to check it out. But now when we talk about the goal of platform engineering, the goal of platform engineering is to provide a scalable, robust, and efficient platform that enables developers to build and deploy applications more quickly. So these two definitions may seem a little bit similar, but to sum up, platform engineering provides the foundational infrastructure and tools necessary for implementing DevOps practices. So it provides the infrastructure and tools which is necessary to implement the DevOps practices, such as CI/CD, automated testing, infrastructure as code, so on and so forth. Goals. The key goal for platform engineering is to create a self-service model where developers can easily access the tools and resources that they need without waiting for the operations team. So this is like an extension of DevOps. When we talk about the DevOps, is like what the aim is, to reduce silos between the dev and operations team. What does it emphasize on? Platform engineering often emphasizes on building platforms that are scalable and standardized, which means that it can handle the growth and are consistent for all the users. DevOps, on the other hand, focuses on scalability. So it is an approach which is more centered towards the CI, like continuous delivery and integration. Some people may see platform engineering, like as I already mentioned, a step in the, like an evolutionary step from DevOps. So the term DevOps versus platform engineering is not really true. So as the tech landscape becomes more complex, we are seeing that the role of platform engineering is growing in creating more comprehensive platforms that support the wide range of development needs. Okay, when we talk about DevOps, automation is key. So it's about tooling and automation. So what do we mean by that? This includes automation of code deployments, testing, infrastructure provisioning, monitoring, and feedback loops. Tools in DevOps might include like CI/CD pipelines, config management tools, monitoring solutions, while utilizing, while also utilizing automation. Platform engineering focuses on creating the platform itself. Okay, so this includes, which we're going to talk about later on, internal developer tools, cloud infrastructure setup. So if you're using Civo, Kubernetes, this is the infrastructure that you're using, service meshes, API gateways, so on and so forth. Now, who uses it? So DevOps practices are generally adopted by both the development and operations team. Platform engineering primarily targets developers because here's a platform, go use it. All right, cool. At Civo, last year, we did a survey result, and the results were pretty interesting. So 85% of the organizations have either partially or fully adopted a DevOps culture, emphasizing its continued relevance and growing in the industry. Only 40% of the respondents in the DevOps roles reported a moderate to high level of familiarity with platform engineering. So people who are already using DevOps, only 40% of those people mentioned that, okay, yeah, we know what platform engineering is. That was last year. Among organizations that have adopted platform engineering, around half of them said that it improved standardization, and around 43% said that it saw faster product delivery. Future of DevOps, around 65% respondents in our Civo survey mentioned that they strongly agree that platform engineering is the next evolution of DevOps. And the number one challenge when we talk about why people are not doing platform engineering is resistant to the culture in the organization. So like trying to convince people like, okay, let's adopt this culture. And emerging trends, we don't have to talk about that, like GitOps, AI, machine learning, everyone knows. That was also one of the parts in the surveys. Cool. Let's talk about internal development portal. It's like a one-stop hub designed for software developers within an organization. So it's like you can think of it as a private online toolbox where all the tools are there, guidelines are there, resources are there, and support is needed, that is needed for software developers, all in one accessible place. And this includes like software libraries, development tools, testing services, documentation, so on and so forth. Advantages, so many, like customization tailored to your own unique needs based on your organization. Full control over the security, compliance, and configuration of the software and data, easily integrating in your existing systems and sources, and cost efficient for a larger scale. The challenges when we talk about internal developer portals, like something you're building on your own, is obviously because you have to build it on your own. So maintenance and upkeep, you have to do it by yourself. Initial setup cost time and all these other things. Scalability challenges. You might require additional resources, and dependence on the internal IT team, so people who made that. That's one way to do it. Other one is you don't build it on your own in-house, you use a SaaS solution. And advantages include very easy, you just add your credit card and you're good to go. So initially the costs are lower, no maintenance hassles, scalability, and pretty standard stuff. Challenges as well. Pretty self-explanatory because you're using a SaaS platform, so you don't have that much of a flexibility or wiggle room. So less customization. People may change their subscription fees, and sometimes it may lead to vendor lock-in. Like Mark, if you caught Mark's keynote, mentioned about that. And because you're relying on a other provider, so data security concerns, however they handle your data, and you're dependent on the internet and that vendor. So what do we pick? How do we pick which one is best for you? What I would recommend is start by taking a comprehensive inventory of your current DevOps practices, tools, and culture. So think about what's working well and what needs improvement. And a critical aspect that we saw in our survey was lack of standardization when implementing DevOps practices. So consider how these factors might influence your operations. Once you have done that, think about what do you want to achieve with platform engineering? Is it faster times, faster delivery times? Is it improved standardization, increased efficiency? So if you have clear objectives, that will help guide your transition process and also help measure your progress. Identify the necessary skills and tools. So in our survey, GitOps, AI/ML, DevSecOps, developer platforms, and serverless computing, they came out as emerging trends. So evaluate which skills and tools are relevant to your organizations and how you're going to plan to acquire them. And other thing is, when we talk about tools, platform engineering is as much about culture as it is about tools and technologies. So cultivate a culture of that emphasizes on learning, collaboration, and transparency. Next step would be creating a detailed roadmap for your transition. So phases such as pilot projects, a broader implementation, and continually refining the platform. When you're doing that, avoid attempting to change everything at once. Instead, implement gradual changes and learn from every single step. And in our survey, which I mentioned already, resistance to change was a significant challenge in implementing DevOps practices, and a similar challenge can be expected here. So instead of attempting to change everything at once, just do it step by step. I only have 5 minutes left, so I'm going to wrap up. And then, you can measure progress and refine and improve. Demo time. I'm going to do a demo. Actually, I'm going to be done with my slides first. After the demo, what is next in platform engineering? I think next step is abstraction. Cloud providers provided this abstraction over virtual machines. Kubernetes provided this over containers. And now platform is doing it over services and applications. So I think in the future, we're going to see further drive for automation, making it more accessible for engineering teams. Some of the challenges that people might think of is how to make it more secure, so compliance for larger organizations, in hybrid environments, balancing complexity. I think in the future, teams will be smaller, so do more with less. I think that's the way I'm looking at this year. So more automation, but more building blocks are also essential. And we're also seeing like integration of AI and machine learning into platforms. Taking our cake analogy, it's like you have now a smart assistant in your kitchen that learns from your recipes and suggests new recipes, whatever. Resources, there's a platformers.community you can check out, Civo webinars you can check out, Civo YouTube you can check out. This interview you can check out at Platform Engineering at HubSpot. This another interview you can check out, Platform Engineering at Shopify. No thank you. No thank you yet. I have a demo yet. So we'll do a quick demo. And it'll only take a minute. Okay. Nope. Mirror on the wall. Okay, that works. Right. We're going to use KubeFirst. Instant GitOps platform. Website is pretty cool because my time is short, so I'm just going to walk through it, but I'll show you a demo as well. So all the technologies and stuff you use, everything we spoke about, right? We spoke about monitoring, we spoke about infrastructure, we spoke about CI/CD pipelines, we spoke about all these other things, Docker and everything, containers. KubeFirst can help you do that. And so you can see business impact, platform engineering foundation, so on and so forth. You can check out the websites, very cool, and check out their GitHub repository. So you can see open sourced. I think they're a part of CNCF, I'm not sure, but I think there are many other projects by the KubeShop community, which is part of CNCF, but either way, good open source project. If you want to get started, so just create a new cluster. It's in our Civo marketplace, so pretty easy to get started. I'm just going to give it a navigate demo. I'm going to have one node, medium, default is fine. This I'm just going to select K3S, version, Cilium is fine. And here you have KubeFirst in the management section. So you'll find KubeFirst over here. And create your cluster, and that's it. You will have KubeFirst installed, and rest of the stuff in terms of like how to set it up and everything, you can find on the docs. But this is basically what the platform looks like. Here are the applications. There's a GitOps catalog. So let's start with architecture, move on to like CI/CD, security. Some good practices include not having security at the end. So having this secure culture from the very start of your project. Kubescape, if you don't know, it's an open source project it's in the CNCF landscape by Armo. So it scans for vulnerabilities in your Kubernetes clusters. So you can just click on install, and that way, using KubeFirst, you'd be able to do that. My cluster should be up and running in like 90 seconds. And yeah, you can check out other applications. You can also check out the environments. So development, staging, production, you can create newer environments, give it a label, color, and then depending on that, you can deploy your applications. But I hope that was helpful in order to explain, what is the difference between platform engineering and DevOps. And yeah, I think just experiment, have fun, and try out KubeFirst. And thanks for coming to my talk. Thank you.